In this video, we're going to be looking at the distributive property, which is really important because you're going to be seeing a lot of it in the future. So, in general terms, the distributive property can be written as A times the quantity of B plus C equals A times B plus A times C. And this isn't only limited to three terms as it is here, like A, B, and C. In fact, it can include any number of terms. So you could have A times B plus C plus D plus E and so on, and you would just have to do the same thing and write it as A times B plus A times C plus A times D plus A times E. And it just goes on and on like that. So to start off, I'm going to try to give you some more simple examples, and then I'll try to get more complicated as we go on. So first off, let's start with 5 times the quantity of 4 plus 2. So there's two ways of doing this. The first way is we can do what we know how to do and do the order of operations and just add everything in the parentheses and multiply it by 5. So 4 plus 2 is 6 in our parentheses times the 5 gives us 30. So that's one way of doing it. But with the distributive property, we can go with this 5 times the quantity of 4 plus 2, and we can do what we have done up here in the rules. You can just go 5 times 4 plus 5 times 2. So 5 times 4 plus 5 times 2. And 5 times 4 is 20 plus 5 times 2, which is 10. So 20 plus 10 equals 30. And as you can see, both ways work just fine. So let's try to throw something else in here just to prove that we aren't limited to 3 terms as we have been so far. So let's go with something like 4 times 3 plus 2 plus 1. Okay, so again, there's two ways to do this. So let's first start by adding everything in the parentheses and multiplying by 4. So 3 plus 2 plus 1 equals 6 times 4. And that is going to give us 24. So now let's do that using the distributive property. So 4 times the quantity of 3 plus 2 plus 1. So 4 times 3 plus 4 times 2 plus 4 times 1. So here we go. 4 times 3 plus 4 times 2 plus 4 times 1. And 4 times 3 equals 12 plus 4 times 2, which equals 8, plus 4 times 1, which equals 4. Sorry about that. So 12 plus 8 equals 20, plus 4 equals 24. And again, they are the same answer. So now let's try to get a little bit more tricky here. And go with some variables. Now this is really the reason why we even do the distributive property, because as you just saw, when we only have numbers, it's actually probably easier to just go with what we know how to do anyways and ignore the distributive property. But when we have variables, that's not an option. So let's go with something like 3 times A plus 2. So now, unlike before, we can't just add everything in the parentheses and then multiply by 3, because we don't know what A is. So this is where the distributive property comes into effect. So what we have to do is go 3 and distribute it throughout everything in the parentheses. So 3 times A plus 3 times 2, which is 3A plus 6. So that's how you do the distributive property with variables. So now let's do that just one more time just to solidify this, only now let's move the variable outside the parentheses. So now we have a B times 3 plus 2. Now with this one we could just add everything in the parentheses and multiply by B, but in keeping with the distributive property, I'll do it that way. So B times 3, which is 3B, plus 2 times B, which is 2B. And we can add these two together since they have common terms, and we would get 5B, which we would get if we just added the 3 and the 2 to get 5 times b, so 5b. So now let's take things up a notch and throw some more variables at you. So x times 2y minus 4z. Now this is a lot more common to see with the distributive property, because there is no way that we can just add the things in the parentheses and multiply by the thing on the outside. We actually have to distribute this x through. So starting off, we're going to get x times 2y minus x times 4z. Okay, so now x times 2y is just going to be 2xy, and then x times 4z is just going to give us 4xz. So there's a more complicated example for you, but now let's try to take things up even further by having multiple numbers on the outside of the parentheses. So let's go with something like 2x times 5 minus 7y. Okay, so we're going to distribute this 2x through this whole thing just as we have been. So 2x times 5 is going to give us 10x, and then the 2x times negative 7y, so we're going to go minus 14xy. So that is how you do it with more than one number on the outside. So now let's take things up even further and try to really get things going here. So we'll take something like xyz times the quantity of 2x plus 3xy squared minus xz cubed. And now we're going to distribute this monster here. Now just like before, it's just going to be this whole term right here times this term, then this term, then this term. Don't make it more confusing than it is. So here we go. We're going to have we'll have xyz times 2x plus xyz times 3xy squared plus xyz times, sorry about that, that's going to be a minus right there, times xz cubed. Okay, now we just got to expand all this stuff out. So 2x times xyz is just going to give us 2 times x squared, because we have 2 x's here, yz, plus this one now, which is going to be 3x squared again because we have 2 x's, and now we have y cubed because there's 3 y's, because there's 2 y's here and 1 y here, z, minus this term, which is x squared once again, y, and then z to the 4th, because there's 3 z's here and 1 z here. So that is how you do the distributive property.